Hello, geometry classes. We're going to take a look at lesson 10.5C guided practice problems today, where we're going to use the relationships of angles inside and outside of circles. This is part 2 of lesson 10.5. Today we're going to concentrate exclusively on the theorem 10.13 that talks about those angles that are outside of the circles. And we're going to see in each of these diagrams that there is an angle outside of the circle formed by either a secant and a tangent ray, or by two tangent rays, or by two secants. In each case, there will be two arcs that are intercepted, a blue and a red, blue and a red, a blue and a red. And to find out the measurement of the angle outside of that circle, we'll do the same thing in each case. To find the measurement of that angle, we're going to subtract, find the difference between the red and the blue arc, and then multiply that by 1/2. Red minus blue arc measurement, red minus blue. And again, once we find the difference between the red and the blue arc, those intercepted arcs, we will divide by 2. That is finding 1/2 of the degree measurement, and that will give us the measurement of the angle outside the circle. Let's take a look at example 3 and see how that works. In example 3, we're presented with a diagram of a tangent ray and a secant ray forming an angle outside of the circle. To figure out the measurement of that angle, x degrees, we're going to subtract the degree measurements of those intercepted arcs, the bigger arc, 178, minus the smaller arc, 176. And then we'll find half of that measurement, and that will give us the degrees of the angle outside the circle. So 178 minus 176 is 102. Half of 102 is 51. So the measurement of this angle is 51 degrees. Guided practice 5 will be similar. This time we have two secants that are intercepting two arcs of a circle. Again, the relationship will be the same. That angle outside will be equal to half of the difference of those two intercepted arcs. So A minus 44, take half of that amount, and that'll give you the 30-degree angle that you see there. So that's what my equation says. 30 equals 1/2 times A minus 44. I'm going to solve for A. First, I'll multiply both sides by 2. And then I'll have 60 equals A minus 44. Add 44 to both sides, and 104 is equal to A. So that means that the number of degrees for this arc here is 104 degrees. Guided practice 6. So on guided practice 6, we're asked to find out what this measurement is for this large arc, X. Okay, so there's going to be a series of steps that we're going to go through, and we're also going to use some ideas that we learned in our chapter about trigonometry a few chapters ago. So first of all, to get ourselves oriented, the diagram that's presented here includes only the blue and the black. Anything I wrote in red, these two numbers here, that's information I added while working on solving the problem. So the first thing we're going to notice is that this number 2 here, this is not designating an angle. It is the length of this segment from here to here, from Q to the side of the circle. They've told us that from S to T, that is a perpendicular line segment, which means it's a radius of that circle, and it is 3 units long. So I've marked all of the segments that actually are the radius of the circle. So from here to here is 3, from here to here is 3, because those are also radiuses of this circle. The next thing that I'm going to need to do is figure out what is this angle measurement here. And again, that 2 doesn't designate an angle. It is giving us the length from Q to the side of the circle. So to figure out this angle, I'm going to be using the Pythagorean theorem and then some trigonometry. First, if from here, from Q to S, it's 2 plus 3, then this hypotenuse will be 5. And then I know that this leg is 3, and I'm going to figure out that this leg is 4, plugging into the Pythagorean theorem. So a squared plus b squared is c squared for this triangle. It's a right triangle. So 3 squared plus b squared, that's my legs. 3 squared plus I don't know, that's going to be my b squared, is equal to 2 plus 3, which is 5 squared. And I'm going to solve that for b, and I'm working my Pythagorean theorem equation. I arrive at b is 4, so that means this is a 3, 4, 5 right triangle. All right, how does that help us? Well, we now can figure out the measurement of this angle here. This angle that is TQS. We can say the measurement of angle TQS is the angle whose tangent is 3 over 4. Remember, for tangent is the opposite over the adjacent leg of the triangle. I'm not going to use the hypotenuse if I'm choosing To use tangent, I'm going to ignore the hypotenuse and just pick up the opposite over the adjacent, and that's this angle here, TQS. Using my calculator, I'll find out the measurement of angle TQS is 36.87 degrees. That means this angle here, SQR, it's also 36.87 degrees because those are congruent right triangles. When I put together the two angles, SQR and TQS, that's going to give me the measurement of this large angle. And so all I have to do is double 36.87, and that will give me the angle of TQR is 73.74 degrees. All right, next. Now I'm going to use the theorem that we just learned about in this lesson. I'm going to take half of the intercepted arcs, the big one, x, minus the smaller arc, 360 minus x, and that's going to be equal to the angle measurement I determined out here that was 73.74. Okay, where did I get the x minus 360 minus x? Well, if this arc is x, and if all together, all the way around the circle, it's 360 degrees, that means that this intercepted arc here must be 360 minus whatever this is. So that's why I have subtracted my two arcs in the way I have. X minus the smaller intercepted arc would have to be 360 minus x. Now I'm going to simply solve this equation to find out the value of x. First step, I multiply both sides by 2, and that will undo this 1/2. So there's 73.74 times 2. And then inside my parentheses, I'm going to start simplifying. So I'm going to bring down my x, and then I'm going to use the distributive property, -1 times 360 would give me -360. -1 times negative x is positive or plus x. Then I'm going to combine my like terms. X plus x is 2x. I copy my minus 360, bring down my 147.48. Then I'm going to add 360 to both sides and get 2x equals 507.48. Then I'm going to divide both sides by 2, and there is the arc measurement that I'm looking for, 253.74 degrees. That is this arc here. Okay, that concludes our guided practice problems for this lesson. Please make sure you have this in your guided practice notes, and you're ready now to move on to completing the homework for this lesson, and we'll see you soon.